How many of you know what Docker is? Okay, that's nice. Okay, so since you, like at least half of you roughly know about Docker, I'm going to skip what it is and let's go into why I used it in CI. So what do you usually want from CI? You usually want it to be fast because you don't want to wait in the queue for your build. You also want it to be scalable because suppose you have you are hiring a lot of people like Agoda does right now, and each time we're doing more and more commits. So we need more and more agents to build the Android application. Also, what you want is reproducible build. What do I mean by that? So suppose on CIs there was one build of the application, and then you want to reproduce some particular problem. So the problem is when you want to reproduce it, you have to have the same exact environment for this build. Maybe you have a different version of operating system on which you build this build on, I don't know, on CI. And developer wants to build the same exact bit-by-bit application. So this is another problem which I'm trying to solve. And also you want to secure CI. What do I mean by that? For some builds, for example, what we do is we continuously push to Google Play. And to upload to Google Play, you have to have some credentials because well, it requires kind of a token. So how do you embed it in CI and make it secure so that no, I don't know, some attacker can extract it from the CI? So let's go over how Android application is being built. So for starters, you need some kind of operating system and an Android environment. So what it means? It means Java runtime, JDK, you need Gradle, this kind of stuff. So after that, you're going to build the application with a specific build step. I'm going to run what it means later. And then you want to also run tests. And for Android, some of the tests require only Java environment to run, but some of the tests, they require an actual device. Device can be an emulator that you can spawn on a particular server, or it can be an actual device that you connect via USB cable to the server. And last after this, you want, of course, publish reports, you want some test results, you want notifications, you want to upload, I don't know, to your beta distribution system of mobile application, and etc. So let's go over the first thing. What does Android environment mean? So the problem is, of course, you could set up the environment one time, but the problem is it always updates. So, like the operating system, you probably don't update it at all for the CI. But what is interesting is that so roughly each month you'll get some kind of update. It's either Android SDK, or it's a new version of Java, or something else. Maybe you decided to use a new version of Gradle, maybe it's new credentials, so to upload the application, you name it. So it always changes. So you want the ability to distribute these changes to a lot of agents. So suppose you have 10 or 20 agents that are running on CI, and you want all of them to have exactly the same configuration. So let's go over the approaches that currently exist. So you can have like a swarm of agents, you can connect to them manually via SSH, but then there is one particular person who is always doing this. So it's a problem. So you could, how you can improve it? Of course, there are tools that simplify this configuration. I don't know, Chef, Ansible, maybe you would use Puppet or something else. The problem comes is when the developer wants to reproduce the same build on his particular machine. And this machine can be OS X, it can be, I don't know, Windows, whatever. So how do you get this the same configuration on the developer's machine? So with kind of Chef and Ansible approach, you would connect this machine to the system, but then maybe you don't actually want to do that. So how we solved it is using Docker. What Docker provides is a reproducible image of an environment. So in this case, we use Docker repository, which contains images for our Android build, and developer can always pull the image of this environment and build inside it. And it can be like on Windows machine, OS X, whatever. Okay, so the nice thing also about this is if you update your environment, Docker does the diff between what was the previous environment and the new one. So if you have this army of agents, and then you push one update, and this update maybe it only changed like, I don't know, 2 bytes. So what Docker will do is only update these 2 bytes and not download the whole image of the, I don't know, virtual machine in some cases. So it will be like smarter than that. Okay, so how to build the Android application? So usually it's one simple command like this. In case of Docker, this would look like this line. So basically you would run a command in a CI Android image, and you would mount the source of the application. Inside this container, you would run the usual command as if you would do like without any Docker, you would gradle assemble. So what is interesting about this? So there is a fast startup in this. So Docker starts this command immediately. You don't need to wait to spawn another machine, like a virtual machine, for example, if you would do this inside VirtualBox or VMware. There is also no state inside this thing. What do I mean by that? So suppose you would run the CI on an actual machine, an actual server. You would need to invalidate caches. You would have the dependency cache, compilation cache, like anything that is built, and the output of the build, for example, for our application right now is something like 4 gigabytes in total if you build everything, and I mean all the possible versions of the application. What else? And when you do this, you also have the nice benefit of, for example, we're now distributing the release keychain for our application inside the image of Docker. So on CI doesn't know anything about like how the credentials or anything. So as soon as we need to update them, we won't update the image. Okay. So let's go to the testing phase. So this is the tricky part. So the things that you can run on the JVM, of course, they're simple. Like you can have Java virtual machine inside the container. You would all run it like easily. But the problem is with instrumentation tests. Instrumentation tests, they're part of Android testing framework, which require an Android instance. So two approaches that you can do is you can run an emulator. Maybe it would be emulator from Google. Maybe it would be a Genymotion or some other third-party solution to start an Android instance. But the problem is it is not reliable in terms of the test reports. So each time you run a test on the emulator, it almost always has a false positive. I mean that the actual application might fail on an actual device, even though everything is green, everything is passing. So the goal is to detect these kind of problems early. And the problem is how to connect the server instance. For example, your servers in a data center, you don't have them. You don't have the availability to connect to them physically. So you want to connect via some kind of network layer to them, and that would give you the benefit of having the actual test results. Okay, so this is what it would look like. So you would have an army of agents. You would have a test lab that has like number of devices. So how do you connect to them? Preferably via network. And the only thing that I found that that can solve it at the moment is there is one open source project which is called OpenSTF. It basically allows you to well, it has complex architecture in terms of how it's created, but basically you can access any device via TCP/IP. So you just connect to it via network layer, and that's all you need to take care of. The problem is this product is only focused more on the developers who want to test manually. So there is no command line interface. There is nothing. You have to go to this website. You have to log in there. You have to. It has like very complex startup in terms of their load balancing, etc. So the problem is how to connect to this from CI. So they provide a REST API which are wrapped into a command line application. You just basically connect. You request from the STF a token. You can connect to any device from the test farm, and then you disconnect. So basically the flow is you execute disconnect command, then you run your thing that you want to run on an actual device, and then you just disconnect from this. The nice benefit of this approach is that at the same time this is what it usually looks like. You can, at the same time, when you have like on CI something is failing, you just go to this web interface and just see how the tests are actually executed. If something is wrong, and for example, lots of devices, they have custom firmware, and sometimes they have like a pop-up which just overlays everything. So your test cannot run just because Samsung wants to release an update every week. And you can go to this thing and see like this is actually the problem. So before that, what we did was just we actually went to the devices and look at them and like, oh, here is another problem, here is another problem. This way you can actually take care of the device farm at least easily. Okay, so the whole process is like this. This is the whole diagram of what our CI currently looks like. So there is a maintainer, basically this is the person who oversees this. So the whole architecture is confirmable from source code. So we have a Git repo which basically says this is the image of Docker which builds currently our CI. CI actually builds this image from source code, then pushes it to the Docker repository. Then this Docker repository publishes this to all of the agents. This is done not by push, it's done by pull. So each agent, when it runs a new build, it just pulls from repository the new version of environment, and then just executes the build steps inside. And when the agent needs the connection to a real device, it goes to the test lab and requests a new device. Currently we're doing like randomizing each build because we don't have enough devices of the same type. So maybe the build queue is like five or seven builds. We can't guarantee that all of them will have the same device at the same time. So it is randomized. Okay. So the thing is, the nice thing about this is you can scale this. And this was by design. So if you want to scale this, suppose you have 10 developers coming to the team, and what you need is to add agents, and you want to add devices which can actually run tests. So in terms of agent, you basically just install any operating system, install Docker in it, that's all.
One question, sorry.
Yeah.
You said that Docker provides us some operation system setting environment, yeah?
Correct.
Why Docker can't create some like some environment like Android OS?
What do you mean Android OS?
And launch application directly on Docker. Is possible or not in the future, maybe?
I haven't seen projects like this. Theoretically, I would say it is possible because Android is Linux, but it's a very custom kernel, and the Docker runs on the kernel of the host operating system. So you would probably have to modify the OS that actually runs Docker. But I don't know. Maybe it's possible if you do like custom kernel compiling. But right now, just without any modification, it's not possible. Yeah, and in terms of adding devices that actually run tests on them, so you just need to connect another device to the smartphone test lab, and that's all. It's just automatically there, available for people to use it.
Why are you guys maintaining your own hardware test lab? So I'm not too familiar with all of the stuff, so maybe the question is.
Yes,
but I know like Xamarin, they've got this whole.
Yeah, of course. This is a good question. So why not use the basically test farms that are available out there, like cloud providers? So the problem is like these cloud services, they don't provide you like good network implementation. So our tests actually, they do not mock the network layer. They actually go to our web servers. And the problem is usually these cloud labs, they don't provide you with a reliable network. So you cannot guarantee that they will have stable internet connection, and then the test fail just because there is no connectivity there. Apart from that, we have our internal servers, which you can't access publicly. So how do you, if you have a public cloud and you're using that, so how do you get this connectivity to our internal staging servers? It's just not possible. Also, another thing is that we have the full control over the whole cloud. So, for example, with the CI, one can say, why don't you use like Travis or something else, right? But in Travis, they have a very generic build for Android. So you can build there, but it wouldn't be as fast as we have. So we have like specific configuration. We don't install Android artifacts on the build because Travis spends something like 1.5 minutes or 2 minutes just downloading from the internet again Android SDK. And we have it already embedded in the image. We don't need that. We just spawn the container and run inside already. So it's like as fast as possible. So does that answer the question?
Yeah.
So some of the things, well, I didn't know where to put them basically. So it's just general tips for building these kind of things. So in terms of CI, when it actually builds, you want to use as fast as possible the storage that you use. So for Android, it is much the case because even though I tried increasing like the number of cores, it just doesn't scale. The bottleneck is the I/O for the build. So you want to use RAM disk as much as possible for the build. And not only for the actual Java compilation, you want to use it also for dependencies. For example, we have 40 plus dependent jars or ARs for Android that we have to store on the build, and all of them are also on the RAM disk. So another problem is with the tests, with the devices in the test farm. So they always have some buggy implementation of ADB, which is the Android device bridge, which basically allows you to execute tests, allows you to install applications. So the connection just sometimes it just disconnects, and then you have to go manually restart it or something like that. So you want to root the device and possibly remove all the bloatware that manufacturer installed, and that's one other tip. So another thing with the test lab, so if you start building this kind of thing with a lot of devices, of course maybe you have like 4 ports on your PC, Mac or whatever. If you connect all of the devices at the same time, they don't have enough power. So this is one of the limitations of how to build the device farm. So you have to buy USB hubs that have external power. And you have to be very careful about that, because some actually claim that they have, I don't know, 40 watts, but it's not the case. Okay, so basically that's it, what I wanted to share with you guys. Questions?
Do you see anything similar on the iOS side?
So these guys, they have a ticket open on GitHub to implement the support for iOS. It's not on their roadmap. Of course, pull requests are welcome. The problem for them is that their product is focused more on showing screens from a remote device. And iOS, before iOS 10, they don't have this support at all. So since when the iOS 10 will come, they will probably think about it again. But not in the moment.
So when you deploy your APK, you do it through ADB, right?
Deploy to the device.
Yes.
Yes, correct.
Would it be possible not to like have some kind of mobile agent to pull it through Wi-Fi or TCP instead of ADB?
ADB works over TCP stack right now, and this is how it's actually deployed to a remote device in a test farm.
What about the STF client implementation? Have you released the project? So the client?
Yeah, of course, it's available. I think I put the link. Yeah, on the bottom.
What are the internals of the client? So it's the
It's basically a REST implementation of the REST client that is inside the OpenSTF, and it is a Ruby gem that you have to install as a gem install STF client, and then you just run it as a command line application. There is also a help there.
My question again. It's possible to run emulator on Docker, inside Docker?
Emulator?
Yes, imagine we have like an image of Windows operation system. Yeah, inside we can launch like Genymotion. Is possible?
No, unfortunately that's possible. It's a limitation of Docker. Currently it supports only like containers that are built on top of Linux kernel. So even if you actually when you install Docker on Windows or on OS X, it just spawns another Linux machine in which it runs the container.
And finally, in this case, we have only opportunity testing by a real device hardware.
Yes, but of course you can for this test farm. It doesn't care about like if it's an actual device or not. You can connect emulators to this thing also. It's just like this decouples the devices that you actually run tests on from the agents which are run inside CI. So you have the full control over like what you want to test on. So maybe it's in a device like a real device. Maybe it's an emulator of Google. Maybe it's Genymotion. Maybe it's something else. Maybe you build some custom, I don't know, image. So.
You mentioned SDF client uses TCP to connect to the device. Is that right?
Yes, correct.
Do you go over the Wi-Fi with that?
Over what?
To Wi-Fi.
You mean Wi-Fi of the device?
Yes.
Unfortunately, I researched this part because, of course, it's a problem. Like you have, I don't know, 40 devices on the, I don't know, maybe on this in the same space, like it's 1 square meter. For some devices, it depends on the Linux kernel that is inside the device. So sometimes it has an option to support a USB Ethernet adapter. That solves the problem, but not all of the devices can do that. It depends on the actual firmware that you have inside the device.
Okay. Have you had reliability issues using the
Not yet.
Okay.
But well, as far as I know, I didn't come to that point. But test labs, they usually do like cage, metal cage, so that you have like at least some kind of separation of the signal.
Yeah.
Few time ago, maybe 1 month ago, Facebook published the article about testing and what do you know the difference? What kind of architecture they prefer? Facebook.
I don't know about their
and
architecture,
engineering?
unfortunately.
Okay. Okay.
What's the difference between having this kind of test lab in-house and between getting like surface services?
Well, this question was already asked, but again to clarify, so you have full control over your devices, and you can you have your own network implementation. I mean, for our case, for Agoda, we can access from these devices our internal servers. From a public cloud, you would not be able to do that.
Yeah, but I will ask the question a little bit differently.
Okay.
Like, what's the difference on running these tests on our devices and running these tests on other test labs? Like, is there any difference in the test results?
Apart from what you can actually access from these devices, the difference is some clouds, they don't provide you with a real device. They provide you with an emulator, which probably runs on QEMU, with a firmware that they got from the manufacturer. And there is always a price difference in terms of time that you request from an actual device and this emulated device. So as far as I remember, Google charges something like $5 per minute for a real device. So you can imagine if we run, for example, on 10 devices almost all day, this would get a very much bill for us.
And what about speed? Is it faster to run the test on the embedded device or on the real device?
Almost usually it's the same time of execution.
Any other questions? All right. Thank you, Anton.